So guys, we are starting with AZ-900. So that is the fundamental course for this thing. And these are the modules that we have in Azure AZ-900. So first module will be your basic cloud concepts. Then second module will be around your Azure core Azure services. Third module will be around core solutions and what are the management tools that you have. And we also have labs for these modules. So maybe I'll take you through the labs also so that you get better acquainted to the Azure portal itself, and you can actually do a bits of hands-on also. And then module 4 is around general security and network security. Module 5 is around identity, governance, privacy, and compliance. And at last, we'll see Azure cost management and the SLAs that are there in the service. So let me just start with the module 1, the cloud concept. So this was my introductory slide where uh, uh, we are explaining what all we'll be covering, and let me just reshare my screen with module 1. Okay. Yeah, guys. So can you just see my screen? Just quickly, just put it in the chat. No need to unmute. I'll just. Is my screen visible? Okay, great. Okay, so yeah, let me just get. Okay, so the first module is around cloud concepts, and the module agenda will be around that. What we will be learning in this module is first we will try to understand different cloud models that are there. So what is the difference? What is a public cloud? What is a private cloud? What is a hybrid cloud? And then in which scenarios you will be choosing the best out of the three cloud models. Then we'll move to cloud benefits and consideration. So why is everybody like moving towards cloud computing? What are the benefits that it offers? And then what are different cloud considerations? At last, we'll see how within your cloud different services are segregated or categorized between IaaS, PaaS, and SaaS services. And at last, we'll see the sharing responsibility model that is there. Okay, for cloud models, we'll be seeing first what is cloud computing, then we'll describe public cloud, private cloud, hybrid cloud, and then we'll compare and contrast the three different cloud models that are there. Okay, so guys, cloud computing, if I say it's simple as these four things that you see, first is your compute, then you have networking, next is your storage and all the analytics that you need. So computing is nothing but the delivery of computing services over the internet. And obviously once you have all of these things at your disposal, you can actually faster you that actually enables you to have faster innovation, flexible resources, and you have economies of scale. So this is very important. Most of the organization are moving towards cloud computing because there is economies of scale, and most of the time they don't have to invest in any capital expenditure upfront. Rather than what they go ahead, they rent out solutions, and those solutions are they rent out depending upon what capacity do they need. So that is all in all what is cloud computing, and most of the time you'll be renting these four things only from a cloud provider. Okay, so then we have your public cloud. So public cloud, these are owned by your cloud services or your hosting providers. And so these hosting provider could be your AWS, it could be Azure, it could be your Google Cloud. So all of those are actually cloud computing cloud services providers that are there in the market. And then what they do, they provide you resources and services to multiple organizations and users. So this is also important whenever you're whenever you go and spin up anything over any cloud, be it Azure, AWS or GCP, you are actually using those resources and you are actually sharing those resources with multiple organizations. But somewhere how they are doing it behind the scene is something that though that cloud provider only does that for you. But maybe the hardware that they have bought, they are actually renting even small spaces, small pieces of their hardware to different organizations. Okay, and at last, a public cloud, it is accessed via a secure network connection, and it's mostly over the internet that we'll be accessing our cloud platform. So through the internet, all you have to do is just like a website, you have a portal for all of the providers where you can just go to their portal and you can just start working and building your uh, platform the way you want it. Okay, post this, you have your private cloud. So private cloud, just like if you look at this image, this is a cloud, but it is tied to an organization only. So just similarly, this organization creates a cloud environment in their own data center. So this private cloud is not something that other organizations can actually use. This is something it is created by the organization in their own data centers, and the organization is responsible for operating the services they provide. So when you're if you were seeing the scenario of public cloud, their Azure or your Azure or AWS or your GCP, they are cloud providers. They are actually responsible for operating those services, provisioning those things that you need. But in a private cloud, the organization which has implemented the private cloud, they will have to take that responsibility on their own. So that is an additional overhead. Okay, then it does not provide access to users outside of the organization. So if an organization has implemented private cloud in their own data center, so most of the time they will not provide access to users which are outside of their organization. Okay, next topic is around a hybrid cloud. So hybrid cloud, just like the name suggests, it's a combination of public and private cloud, which allows your application to run in the most appropriate location. Now, most of the time you will see most of the organizations somewhere they want a hybrid architecture, and I'll tell you what is the reason behind it. They need the flexibility and economies of scale that is provided by the public cloud. So it's very easy to spin up a machine through any of the cloud providers, be it Azure or any of the three major cloud providers. But somewhere they are very wary about the fact that their data should still be there in their own data centers. So you will see that what they are doing, maybe if it's a banking application, so if the data is very secure, guys, they will still want to keep it somewhere in their own data centers, because if something goes wrong at the cloud provider thing, there is a big outage or there is something, the data is very crucial for them. So they don't want to take that risk. But there are different organizations also which have completely moved to the public cloud also. Why? Because now the cloud computing environment for all of these vendors have matured, and people have started actually trusting them also with the security of their data and the economies of scales benefit that we actually get. Okay, so if I talk about the cloud model comparison, so these are the three main different cloud models that are there. So in public cloud, there is no capital expenditure needed to scale up. So why is it that you are not buying any new hardwares if your application suddenly has more users? So you don't have to actually spend in buying any new hardware, and applications can be quickly provisioned and deprovisioned. It's if you have rented out a server on Azure or any cloud, then you can, if the moment your application is down, you can just simply delete that VM that you had, a virtual machine that you had provisioned, and the moment you do it, you do not pay or incur any charges for that. And you don't have to see that what do you have to do with that hardware also. That is a That is something your cloud vendor will actually take care. Okay. And then the organizations pay only for what they use. So the moment your services are up and running, you are actually you are being actually billed. But the moment your services are maybe in a pause state and you are not even using the compute and other things, then you don't incur any charges also. So that is a benefit of public cloud that is there. So if we talk about economies of scale, so that is one of the major advantage of public cloud. Okay, for private cloud, because the organization itself is maintaining the entire infrastructure, and they are doing it there in their own data center, so they need to purchase the hardware for like setting up and maintenance. And when I say maintenance, you will also have to maintain the staff, the data center guys who will make sure the data center is up and running. But the benefit that organizations get is they get complete control over resources and the security of the things that come with their own data in their data center. But the organizations are responsible for maintaining this hardware as well as updating the hardware and the softwares that are there. That is not, they do not have any other vendor which will do that thing. Okay, then comes your hybrid cloud. So this provides you the most flexibility because this brings the best of both of the worlds. And actually, the organizations determine where to run their application. So maybe within an organization, you will see that there might be some applications which are uh, that need a very secure environment, so maybe they will keep it in their own private cloud. But there are some applications where the data is not exposed in such a manner, and a bit of a loosened up security model can also work with them. So they can actually decide where they want to keep their application, whether they want to do it in a private cloud, or whether they want to do it in a public cloud. And here, organization control security, compliance, or other legal requirements also. Okay, next part is the cloud benefits and what are the considerations. So in this thing, the main objective is we'll identify the benefits of cloud computing, such as high availability, the concept of scalability, elasticity, agility, and disaster recovery. And then we'll identify the difference between capex and like capital expenditure and operational expenditure. And then we'll describe the consumption based model. Okay, so these are the major benefits that cloud actually gives you. First is high availability. So you have the number of data centers that are present with each of the three major vendors is they have so many data centers that are present. So obviously, if your hardware is up and running, the chances of your application being up and running are very high. So you get high availability because firstly they make sure that all the services are up and running, so they have dedicated team for that. Additionally, they also keep on checking their data centers, and the number of data centers that a cloud provider has is much more compared to any other organization if they want to manage it themselves. Okay, then the other benefit is of scalability. So if you want to, if you need a machine which with a even higher computation capacity, you can very easily scale your machine also. So you can simply just there are some auto scalability options where depending upon the load, your service will directly give you higher compute also. Then you get global reach. So if maybe you're sitting in maybe UK, and your most of the consumers, the people who consume your application or services are maybe in the US, then you can have a data center, you can spin your services closer to the users in a data center which is in like US East region or different region. So the performance of your services will be also good, and you will get a global reach to that thing also. Then yeah, you have that agility also where you can quickly spin up, spin down, or provision resources that you need. They come with various disaster recovery solutions also. So there are some region pairs. They've created some region pair also, that if there is uh, a natural disaster in one of the region, your data is automatically replicated into a different region, and the moment that thing happens, you can automatically switch to that particular region. So you have a DR scenario also that is ready. So they, no doubt, they are fault tolerant. By elasticity, we mean that you can scale up and you can scale down at the same time. So it should not happen that if you have scaled up and now you are not using the resources, maybe you had an application and the Christmas season is going on maybe, so you need more capacity. But the moment the maybe your Christmas season is over, that your demands have came down, so your compute and other services should also scale down with that thing. So this scaling up and scaling down mechanism is actually it actually signifies elasticity. Okay, then customer latency capabilities. So if there are any latencies or other things, so you can actually deal with them also. You have predictive cost consideration also. So they provide you that going forward, all the forecasts that you can incur. So they give you all the predictive tools for this also. And at last, this is very important. This is a very important thing for any organization. They need a secure environment where they can keep their applications and their data if they want to go on a public cloud. So all of these vendors are very they are very performant in this way. So they keep their environment in very secure state also. Okay, next is like comparing capex with your opex cost. So like capex is your capital expenditure. So it is as simple as the upfront spending of money on the physical hard infrastructure that is needed, and the cost from capex have a value that reduces over time. So if you buy an hardware today, so obviously it will depreciate, it will keep on depreciate, and the moment you invest in hardware, maintain the cost of maintaining will be small, but you will have to actually maintain it for a very long time. So that is why the cost from capex have a value that reduces over time. Okay, then you have your operational expenditure. So this is the expenditure that you incur, which is spent on product and services as needed, and you pay as you go, and they get billed immediately. So if you need any operational things that are going on, and even your maybe your manpower is also an operational thing. So you spend on people, you spend on products, and you mostly do it in a pay as you go manner. So okay, so for all your cloud providers, uh, there is a consumption-based model where your cloud services provide you, which means that the end users only pay for the resources that they use, and whatever they use is what they pay for. So it should be only the things that you are using, and the amount of the services you are using, you will be only billed for that particular thing. So this gives you better cost prediction. Prices for individual resources and services are also provided. So you will get to know that if you are provisioning a VM, what will be the hourly cost for this particular virtual machine, or maybe if you are hosting an application on any app services or anywhere, you will get to know that what is the price this application you will be actually incurring. So then you can take an informed decision whether uh, uh, what sort of hardware you should go for, what should be the infrastructure that you would be needing. And at last, billing is based on the actual usage, so there is no additional if, even if your application was running for maybe 8 hours, and yeah, so you will be only billed for 8 hours, even though maybe in that 8 hours you need it for only 8 hours, so you won't be billed for the entire day. You will be billed for the actual usage only, and for storage also. So if you're using maybe 1 TB of storage, you will be billed for that 1 TB of storage only. not for the entire hardware that was bought by your vendor. Okay, for cloud services, so we'll first see that what is infrastructure as a services, and then we'll understand what are PaaS services, and what are SaaS services. Then we'll identify different service type based on their use cases. Then we'll see the shared responsibility model. So this is very important because here we differentiate what is the responsibility of the vendor and what are your areas that you need to focus. Okay, and at last we'll see something new these days that is very trending, which is known as serverless computing. So no doubt there is a server behind the scene, but you do not manage that server. So that is why it is known as serverless computing. So we'll see that what is serverless computing also. Okay, so let me check whether there are any questions in the chat or not. Okay, none so far. Okay, first is your infrastructure as a service. So here, if you see the three things that your vendor is providing you, he will provide you all the servers and storage that you need, the networking, firewalls, and security, and the physical data center, what all boxes and racks that are reserved for you, they'll be reserved for you. So in this, what you are doing, you build a pay-as-you-go IT infrastructure by renting out servers, virtual machine, and storage, and the underlying OS and other things from the cloud provider. So you are just renting out the infrastructure. Anything over and above that is needing is it will be managed by you only. So this is known as infrastructure as a service, where the only thing you're renting from the vendor is the infrastructure, the server, the storage, the networking, firewalls, and security, and the by data center physical plant and building. So obviously you will if compute or storage is dedicated, it will be dedicated in some data center where there will be a physical rack kept for your compute. Okay, then comes platform as a service model. So in this, it provides the environment for both building, testing, and deploying software applications without focusing on managing underlying infrastructure. So here in IS, you have to, once you have the infrastructure provisioned for you, you have to manage the underlying infrastructure. But in PaaS, you don't have to do that. So they manage the underlying infrastructure for you. So all your OSs, updates, and everything else will be taken care by them. All you have to do, focus on is on your application. Okay, then at last comes your software as a service model, where the user does not care what application development and anything. All he does is it's a subscription based model where he's actually consuming your service. So it could be your Office 365, your emails, and your calendar. So all you do is, there is an hosted application somebody has already created. You maybe you have bought that through some subscription or other things. You go ahead, do your things, and you don't care regarding the infrastructure, whether the application is in a secure state or not. Nothing, that is entirely taken care by your cloud vendor. So these are the three main so different services as a model, where as and when you go to from IaaS to a SaaS platform, the responsibility at your end is reduced. So you don't have to manage a lot of things. The vendor is automatically taking care, like sharing that load for you. But obviously that thing will come at a premium. So maybe they will charge you something extra compared to if you would have to build your infrastructure according to you. But no doubt, if you see the in IS itself, a lot of things are already taken away from you, which were very complex previously, like managing your data center, provisioning everything, making sure that you have the hardware, as much hardware that you need. Okay, so if I compare this cloud services, first thing is your in your IS, you have the most flexible cloud service. So you have the entire governance over your infrastructure. What do you want to build? How you want to build? How do you want to administer? All of those things can be taken care by you. You don't need to worry about. You have the highest flexibility. Okay, here, but you have to configure and manage the hardware for your application, which can be a very tedious task for like a lot of organization, because they will have to have resources who actually understand those things, and even the data center guys and other people means you will have to understand all the administration part that is needed. But in your PaaS application, you the flexibility of it is taken away, but then the complexity of managing your application is also is taken care by your vendor. So you only focus on the application development. The platform management is handled by your cloud provider. So you do not manage the platform when you are working on PaaS services. Okay, at last you have your SaaS services. So they are like as a pay as you go pricing model. So the users pay for the software they use on a subscription based model. So just like Office 365 or any of the popular websites that you see, where all you come and use their services, where somebody has taken a subscription for on your behalf or you have taken it, like Office 365. Your app, your company would have paid for the subscription cost, or you can also buy like Office 66 365 the subscription, and you go ahead and use the application for sending emails or attachment or anything, and the all the things behind the scenes are managed by your cloud vendor. Okay, then we come to the shared responsibility model. So in the shared responsibility model, this model actually communicates, it is trying to tell you that what is the responsibility that you have, and what is the where is your cloud provider actually responsible when you spin up any of this cloud service. So if we talk about private cloud or on premises thing, this entire thing is your responsibility. So starting from the storage, networking, compute, virtual machine, OS, runtime, application, data access, everything you manage when you are working on an on-premises private cloud. Okay, so the moment you move to a cloud computing vendor, be it any vendor, so then you would be spinning like any of these three types of service. So either you will be renting just the hardware, maybe you have some platform where you are just want to focus on a platform like on your application development, so you will have a PaaS service, and at last you might be also creating some SaaS based service. So if you have an IS sort of a service, so if when you're working with the public cloud scenario, so the compute, networking, and storage, these three things only are managed by your cloud provider. So you're like setting up your virtual machine, all the OS update, patching, everything is taken care by you. What is the runtime? You develop the application, as well as the all the data and access management is done by you only. But the moment you move to PaaS services, what happens? The underlying infrastructure is also managed for you. So how many VMs will be needed? What will be the OS version? How will OS updates be done? What will be the runtime be like? So all of those things will be taken care by your vendor itself. So the cloud provider actually manages those things for you. The only thing that you have to invest your time is in application development and the data and the access that is required. Okay, additionally, if you do not want to manage the application also, like developing an application is a very costly thing. If you want to, if you don't want to even build that application, you can go for a SaaS-based service where everything is managed by your cloud provider, manages the things for you. only the data and the access is to be managed by you. So your own data and whatever who is actually accessing your application and other things, so you have to manage that. Everything else is actually taken care by your cloud provider. Okay, then like serverless computing. So serverless, the cloud service provider automatically provisions, scales, and manages the infrastructure required to run the code. So in serverless computing, you do not provision anything, neither you have to that compute, and you do not manage the infrastructure, and all you care about is running your code in the cloud, where they do everything for you, and all you have to do is manage the code that you are actually building. So there are two services in Azure which provide you a serverless computing environment. So one of them is your Azure Functions, where your code is running and your service and not underlying platform or infrastructure you are managing, and it will create infrastructure based on an event driven fashion. So one example could be if you are creating an HTTP sort of a trigger, you get, maybe you are building some API or something where you want some sort of code, maybe Node.js code or Python code or .NET code to be run when somebody is actually calling your API. So the underlying infrastructure and everything else based upon that event, it will get provisioned for you, and it will automatically, your code will actually then run. Okay, then you have Azure Logic Apps. So this is also an Azure service where uh, they are basically used to automate and orchestrate your tasks. So whenever you come across this word orchestrate, and I guess uh, Shravanti or somebody said that they were working with Azure Data Factory. So Azure Data Factory is also an orchestration service. So whenever you come across this word in Azure, it simply means they are trying to draw an analogy with uh, that piano, that the musicians that are there, and there is a conductor who's actually just instructing all the musician to play the things, whatever the notes that he wants to play. So that is what is known as an orchestration task, where you have some service which is managing, which is talking to 10 different services and doing the work for you. So all it does is it orchestrates that task for you. It could be orchestrating your task, it could be orchestrating a business process, and whatever the workflows that you need. So Azure Logic App is a serverless computing environment which actually helps you in automating and orchestrating your tasks. Okay, guys. So in module one, we have seen these things. These were like what Microsoft offers. So Microsoft offers like public, private, and hybrid cloud models, and from high availability to elasticity to disaster recovery. All of these things are like you will have these things on the Azure cloud, and be it any cloud, even AWS has it. So uh, uh, this is some these are very common benefits that you get when you're actually using a cloud vendor. And then we have seen like IaaS, PaaS, and SaaS type of cloud service model, and what is serverless computing. And at last, we saw what is a shared responsibility model. So in this module, we only have this thing. So let me start with module two. So guys, if you have any questions, you can. Okay, uh, sure. How do we know our organization is using current model is public, private, or hybrid? How to identify we have managed SQL instance infrastructure? Okay. So Shavanti, when you say you have managed SQL instance, I know it's a PaaS service that you have provisioned. And when you say you have provisioned a PaaS service, so obviously you are doing it on Azure. So you are working on the public cloud. Hybrid cloud, you could be working with hybrid cloud, maybe if you have your own data centers. So that would like that you would only be aware that whether whether your company does have any data centers that they are managing on their own. So if they are managing that, if they are both on the if they are both on the like public cloud, as well as they manage their own data centers, then they are on the hybrid model. But if they're completely based on Azure, on any cloud vendor, then they are on the public platform. And then you said that you have a managed SQL instance. So I understand it's a PaaS services which gives you 100%, like almost 100% capability of migrating your code, and at the same time you do not manage the underlying hardware. So managed SQL instance is not an IS service, it's a PaaS service actually. IS service would be if you spinned up a VM, and on that VM you have actually kept a maybe you have taken a backup of your file, and maybe your DB, and then you are restoring it in your virtual machine. So then all the OS updates, all the database updates that you need, you will be doing it. But once you have actually provisioned a managed SQL instance, all the like being on the latest database updates, patching and everything is actually done by your vendor itself. So they have actually taken over the platform from you also. So I guess that answers your question. We do have a server room. Okay, so yeah, so I guess then you are on an hybrid model, I would say, where you use Azure for maybe spinning up new database instances, but additionally you have a server room. Whether they are deprovisioning those things, I do not know as of now. But okay, got it. So guys, let's take a like 15 minutes break, and let's be we'll be back. I'll quickly have my dinner, and you guys can also take a pause. Okay, we'll start with the next module then. Okay.
This conference will now be recorded.
Yeah, hi guys, I'm back. uh, so let's start with module 2, and this in this module we will also have some labs also, so you will find it more interesting. I hope you can see my screens, guys. Like, can quickly somebody? Okay, yeah. Okay, so your second module is around your core Azure services. So in the model outline, if you'll see, we'll understand what is your Azure architectural components, what are regions, what are availability zones, what are subscriptions, resource groups, and then we'll see some of the major core Azure resources that are there. So compute, networking, storage, and databases. Okay, in the core architectural components, the main objective is what is a region, what is a region pair, availability zones, what are different Azure resources, what are resource groups. There is something uh, there is something they called as Azure Resource Manager, where there is an abbreviation for it also, like ARM, which actually stands for like it is like it is a language in which they actually write their infrastructure. So if you'll go through the template, it will look like a JSON template where you can actually version your code also. So yeah, it is sometimes also known as IaaC, infrastructure as a code. Okay, so the benefit of that things, you can actually have versionable, you can actually commit your infrastructure resources also. So you can have an ARM template which actually using which Azure resource manager can decode what type of infrastructure you want to provision. And because we maintain it in such a manner, like in a JSON sort of a like a file, so we can actually like commit it into a Git repository also. And then maybe like 6 months down the line, you can know what all changes we made into our in our templates, in our in infrastructure template, and you can actually understand what all changes in our infrastructure we are doing. Okay, so that is known as Azure Resource Manager. Then you have your subscription. So your subscriptions are nothing but boundary under which you provision all your resources, like all the cost that you incur and other things. So they are under your subscription. And then you have something that is known as an Azure management group. So management groups are just like creating certain groups where you can dedicate like some subscription to each of the groups, like maybe in one of the management group could be an HR group, other could be finance group. So your finance management group will have further subscriptions under it. So maybe there are 10 different projects that are going on, so maybe it will have a subscription for each of the project, or maybe an of maybe epics. So how you create a subscription, it totally depends upon you, like how you're actually how you want to actually look at the cost of your solutions. Okay, so first thing is region. So Azure offers more like global regions than any other cloud providers. So they have their data centers present in almost 60 plus regions are there, representing around 140 countries. So you have your Azure regions in almost 140 countries. So you can provision your services in these many countries. And regencies are made of one or more data centers in close proximity. So when I refer to a region, so it's not a single data center that will be there in that region. There could be one region also, but there could be, most of the time you will have a region where more than one data centers will be there. Okay, this provides you more flexibility and scale to reduce customer latency. So when we talk about customer latency, assume that you are headquartered somewhere in UK, but your customers are there in your US region and maybe your Middle East region. So what you can have, you can provision your services at these two locations. So what will happen? All the people who will be accessing your services will actually use the data center that is present in your central US, maybe US region, and all your Middle East traffic will go to these data centers. So the customer latency and customer experience will be improved. Okay, and this preserves data residency with comprehensive compliance offering. So nowadays, what happens? Sometimes you have to make sure that the data about your consumers remain within a particular geography. So given, like, I guess GDPR and other compliance are very famous these days, and every techie gets to know about them. So what happens that if you are dealing with the UK citizens, then you have to maintain their data within that geography only. So even uh, if you have a handful of customers who are in UK, by compliance need, you need a region in UK also, because the data sovereignty is like this, that you have to maintain the data in the region itself. So your regions offer you this benefit also, that assume that suddenly any of these countries pass a law that all the data should reside in their own geographical boundary. So if you had physical data centers, the problem would be for you, you will actually have to go ahead and build your own data center at this particular location, because the data sovereignty are like this. So whenever you are working with any cloud provider, you get this benefit that if there are any data sovereignty requirement, you can always provision your services in the data sovereignty location itself. So then your data will be within the geographical boundaries, and then there will be no compliance problems that you might face also. So this is another benefits of having a spread across regions, across multiple countries. Okay, then you have region pairs. So region pairs are, if you see these two pairs, so you can see North Central US and South Central US are two of the region pairs. So there is a replication that is going between these two regions for some services, and there should be at least 300 miles of separation between two region pairs. and they are basically uh, uh, why do they create region pair? The reason is, like, if there is a natural calamity, it will it is highly unlikely that it will affect the entire US. It could be just confined to the north central US part only, but because there some of the services are being replicated to south central US region also. So what will happen if there is a disaster type of a situation, you can always like in the south central US region, you can also, you will have that replication. So you will be up and running within no time, even if the data centers that were present in north central US have been impacted. Okay, and then there is a prioritized region recovery in the event of outage. So what will happen? Assume that a lot of these regions have gone down. So what Azure will do, they will prioritize at least one region within a region pair should be up and running, so that the customer applications are not impacted. So that is why they prioritize region recovery in the event of an outage, and updates are rolled out sequentially to minimize downtime. So if there is a new feature, obviously the vendor is also simultaneously improving their platform. So whenever they roll out any updates, they sequentially do to minimize any downtime. So it will not happen that the updates will be applied both on north central and south central US in one go. So they will do it in a sequential manner. First they'll verify this thing. Okay, so one of the region is up and running, then they will apply those updates to the south central US region. So this way, if there is any issue in applying update in your north central US region, what will happen, that those updates will not actually pass to south central US region. So they'll be first fixed and then they'll be sequentially applied to the other region, and this basically reduces your downtime. Okay, next is your concept of your availability options that are there. So one the within your whenever we talk about availabilities, it's about that how long your resources are up and running. So if we talk about a virtual machine SLA, it gives you a 99.9% uptime with a premium storage. So for a machine, there could be your normal HDD storage, or there are different storage options that are available for a VM. We'll see in our labs when we do those things. So if you are using a premium storage with a VM, there is a 99.9% SLA that is guaranteed by Azure. So the moment this SLA comes below this point of time, so they will actually compensate you back that if this SLA is not met, and this is for a single VM. So it is very easier to lift and shift. Okay, if you have very critical resources that even a slightest downtime you do not need, you can actually go for an availability zones uh, uh, type of deployment also. So you can choose that your virtual machine should be deployed in an availability zone. So availability zone is nothing but it's you can see that there are within a region, the your VM is actually present in like multiple data centers. So the benefit of this is no doubt the redundancy is there, but the uptime will be very better as compared to just a single VM. So here the SLA, if you see, it's 99.99%. And then there are multi-region disaster recovery is always there. So within your region pair, your data is being replicated, and this is done for your like DR cases and scenarios. Okay, so availability zones, they are basically used to protect against downtime due to data center failures. So if you will have your maybe data or your compute in multiple availability zones, that means that your application is being replicated across data centers within an Azure region. So if it's a northeast east US Azure region, so within that multiple data centers are there, and each of the data centers have their own resources. So your be it electricity, your power supply, or physical boundary, everything is a separate entity for your availability zone. So if you have very mission critical application, then what you can have, you can deploy them in an availability zone. So the benefit of this will be your the downtime will come down because the SLAs will increase, and your availability zones are physically separate data centers within the same region, and they have their own independent power, cooling, and networking thing, and they are like connected to a private fiber optics network also. So all of these data centers are already connected through a network, so you do not have to worry about the replication speed given the fiber optics network that is available. Okay, then some of the Azure resources that are there. First, these are the Azure components, major components. So, if for storage, you have your storage accounts, your SQL database, which is your relational way of storing data. For your compute, you have virtual machines and app services, even your Azure functions. And then you have virtual networks and other things which are needed to build like cloud solutions. Sorry, guys. Okay, so whenever you create a resource, there is a in Azure you have a concept of a resource group. So there is no it's just a logical way of grouping your resources. So your resource group is just like a container to manage and aggregate your resources in a single unit. So you can have a resource group, maybe you can name a resource group of uh, maybe GDPR, maybe some website you're creating, the and you have all the resources that are needed for that uh, for that website are present inside one resource group. So that resource group is a it's a logical way of grouping the resources. So you can see there is an app service, there is a VM there, and then there are storage storage account. Another way to group your resources could be you have a resource group for all the VM, for all the storage account, and for all your web and DB. So it totally depends on you and your it's an organizational decision that how they want to create your resources. Sometimes you will have in my industry practice, I see that we create resource group for different environment, for development, like QA environment, and for production environment. So there are three resource group which will have all identical resources, but maybe for based upon varying capacity depending upon the load that the environment has. So we do it that way, but it could be it is entirely an organizational call. So how they want to logically group the resources, it's up to them. Okay, resources can exist in only one resource group, so it cannot be like that a resource is present in two of the one or more resource group. It will be only present in a single resource group. But there is no restriction on the region. You can have your database which is in maybe India region, and your VM in East US region under a same resource group. That is completely fine because it's a logical grouping, and resources can be moved to different resource groups. So yeah, obviously if you want to move this resource to some other resource, that could be done. And application can utilize multiple resource group. So it's not like any hard and fast rule that you cannot communicate to a virtual machine which is present in some other resource group, or a storage account present in some other resource group. So they can communicate between each other. Okay, then we come to Azure Resource Manager. So what happens is when you are building different ways of provisioning your services, somewhere you need a common design language, common service, which actually does that thing for you. So you can actually create your resources from the Azure portal, from Azure PowerShell using the SDKs, using the Azure CLI like the command line interface, or there are REST clients also that are written using which you can provision your resources. Ultimately, what happens, all of these things will be creating some sort of an ARM template using which your Azure Resource Manager will decode what you are actually trying to do with your infrastructure. So it will authenticate, check whether you are authorized to whether do things or not, and then it will decode that ARM template. If it's a data store it is creating, it will do it for you. If you're creating a web app, it will do it for you. Similarly for VM or service management also, like IAM rules and all of these things will be taken care by your Azure Resource Manager. Okay, so your ARM provides you a management layer that enables you to create, update, and delete resources in your subscription. Okay, so what are Azure subscriptions? So your Azure subscription, it provides you with the authenticated and authorized access to Azure account. So if you see that you can have an Azure account, like an Active Directory. Within that, you have a subscription for developers, your test subscription, and your production subscriptions. And the benefit of this thing that they provide you a billing boundary. So if you want to generate separate billing reports and invoices for each of the subscription, you can have different subscription for different uh, use cases. Maybe how you want to see how much cost are we incurring for all the ongoing development activities that we are doing. Have a development subscription. Use this subscription for provisioning all the resources that are used for your ongoing development. Then maybe you can have a test subscription also, where you support your UAT or maybe QA environment. So you can see that what will be the cost that you are incurring uh, uh, for all your testing and your quality data quality exercises. And at last comes your production subscription. So when your application is up and running in live mode, so you can see that actually how much cost you are incurring from the product itself, whether it's actually financially viable enough to have this product or not. So you can take that informed decision also. And then within subscription, it gives you an access control boundary also, where you can manage and control access to the resources. So within a subscription, if you define some policies or the things, you can do those things also, where you control the resources that have been provisioned under this particular subscription. Let me check if there are any questions. Okay, no questions as of now. Okay, so like guys, let me take you to the portal now. It's time to have a walkthrough. So we'll go into the Azure portal. So this is the URL for it. I guess most of you would have been through it, but I'll still put it in the chat window, and we'll see that what all services are there. Okay, so let me just log off for now. I'll re-log in. Okay, so the portal URL is this. Okay, not this one. Okay, this one. So this is your URL, guys. So I guess you guys would have access to Azure environment through your. So you can go to your Azure portal and you can actually log into the portal. And this is how the portal looks like. So uh, you can click on. This is the feel of the portal where you can create these many services. And I guess some of you have already worked with Azure before, so you know how to provision a service. For the ones who have not worked, so like you can, the moment you'll go into this, you will need access to a subscription. So your administrator will actually give you access to a subscription where you can provision the resources. So you can see, even though there are two subscriptions that are disabled for me, but there is an active subscription using which I can provision the resources. Okay. So, and then if you click on create resource, so you can see that you can provision these. These are the categories of resources you can provision, like starting with AI, ML. There's a machine learning service that Azure provides. Then these are cognitive services, like, and you can also provision a data science specific Linux VM, where all your CUDA, your PyTorch, your TensorFlow, all of those libraries will be installed. And similarly, they have created almost service for all of the use cases, like analytics. Like somebody was saying, they are into Power BI. Sorry, they are a BI analyst, so maybe you would have heard about Power BI, and there is a very popular one-stop shop for analytics, which is known as, say, Azure Synapse Analytics. You have data catalogs for lineage and other things, and log analytics for analyzing. So there are several services where you can, which you can actually go ahead and provision for you. Okay, so this is the feeler of the portal. You can actually like click on this. If you have if you are subscribed to multiple directories, you can click on default directories and you can switch directories also. So most of the time it will be a default directory only which you guys will be working on. So this is how our Azure portal looks like. So after this, okay, so then we have management groups. So management groups are nothing but they include multiple Azure subscriptions. So we will create a management group. Within this management group, a lot of Azure subscriptions will be there. And subscription actually inherit conditions applied to the management. So if I have applied some condition on a management group, it will actually automatically get replicated to all the subscription. And there could be 10,000 management groups can be supported by a single directory. So when I say directory, I'm referring to Active Directory. So every organization, when you're logging through an SSO mechanism, they will have some sort of Active Directory which is actually authenticating you. So within an Active Directory, there could be 10,000 management groups, and a management group tree can support up to 6 level of depths. So there could be groups, then subgroups and other things. So there is a 6 level of depth that our management group can actually support. Okay, then we'll move to core Azure workload products that are there. So here we will describe what is a virtual machine. We'll do labs also in this one. So what is a virtual machine, app services, ACI instance, AKS instance, and virtual Windows virtual desktop. So these are compute options actually. What all popular compute options that are available in Azure. Then this is something related to your networking, like networking, security, what is a virtual network, a VPN gateway, and other things. Then comes your storage services, and then comes your databases, and then at last these are some vendor provided solutions if you want. So they are present in your Azure marketplace. Okay, talking about Azure Compute Services. So Azure Compute is an on-demand computing service that will that provides you computing resources such as disk, processors, memory, networking. So you can have a virtual machine. If you have a website, you can have app services. Nowadays it is very popular, like Dockers and other containerization is getting becoming very popular. So they have compute option for that also, like ACI instances which are known as Azure container instances, where you can run your Docker images and other things. And then you have AKS, which is nowadays very popular with deploying your microservices or deploying your ML models. So they are all deployed on Azure Kubernetes these days. And then you have Windows Virtual Desktop. So compared to a virtual machine, if you need multiple sessions, multiple sign-ons for a particular thing, so it's just like a VDI. Windows Virtual Desktop is a VDI type of a service. Okay, Azure virtual machines are software emulations of physical computers. So they have not created any actual like desktop. They are not renting out to you. So they buy compute hardware, and then there are some softwares with which are known as hypervisor and other things, which actually create some sort of a virtual layer over. Sorry, guys, virtual layer over that the virtual partition over that hardware, and then they provide that compute storage capacity to you. So these are actually software emulations of physical computers only, and it includes a virtual processor, memory, storage, and networking. And IS, as we have already seen, that it provides you the highest flexibility, so you can actually totally control and customize your environment. So guys, you can tell me if I'm going fast or slow in the chat. Yeah. So if it this pace is correct, then yeah, we can follow this thing. Okay. Okay. So I guess there are no problems. So let let me have some water. Okay. So the IS offering that provides you full control and customization. So the highest level of flexibility you get is through virtual machines only. Okay, now next we'll go to the labs now. Okay, so for the labs, so I have a Git URL which I will be sharing to you guys. You guys can follow this along. So all the instructions will be there. So just if you want to actually follow along with the lab, you can actually do this. So this is the URL for the labs. Yeah, so we'll go into module two, first lab, which is around creating a virtual machine. So this is we have already signed into our portal. The next thing that we have to do is we have to actually create a virtual machine. Okay, so for that, yeah, so you can either like type virtual machine. Yeah, so you will have this. You will have this service. You can click on this thing, and you can click on create virtual machines. Okay, it will ask you for to choose a subscription. So your subscription could be different from my subscription. And what we'll do, we'll create a new resource group for all our exercises. So I've already created one, but let me go ahead and create one more for you guys. Okay, so I'll click on OK, and then we can name my virtual machine as my VM. We'll choose East US region, so you can have a number of any region that you want to choose, but sometimes there is some quota limit that is present in your subscription. So if I show that to you, you might so you can see if I was choosing a region West US 2, I'm getting this error that I cannot provision this type of virtual machine. So what I did, that I went with East US region, and within this US region I have a quota also. Okay, so here you can have, if you can define whether you want to have an availability zone or a scale set or availability set. So these are currently not a part of your course in AZ-900. If, in a DP or DP 900 series, or maybe DP 203, we can like see them also. So you can place this VM under a particular availability zone also, but this will have additional cost to it, so I'm not doing it. And so for security also, I'm keeping it as standard. And you, what image you want to have on this machine. So whether you are creating a Linux Linux server, or you want to have a Windows 10 Pro machine. So whatever you want to do, you can have it. So in our labs, if you go to the lab, so you can see that they are actually they are provisioning a Gen 2 Gen 2 machine, and the size of this machine is standard DS2 V3 machine. So the reason behind this is they uh, every virtual machine has some it is part of some category, like a D2S series is it might be a different type of a machine, like compute optimized, memory optimized. So they have actually given some specific name to virtual machine categories also. Okay, so DS1, I'll go with V2 series, and I'll choose Gen 2 data center image for this. Okay, username you can put it as Azure user, and password also we can use same password so that later on we do not have any. Or you can also provision your own. You can write your own passwords also. Okay, for then for this virtual machine, if you can see that because obviously we will be using some remote desktop client to connect to this machine, and so we will have to open some inbound port. So automatically it is giving us an option that because this is a virtual a Windows type of machine that we have provisioned, so it is opening port 3389 for us, using which we can do an RDP into this. And if you have your own existing Windows Server license, you can actually use Azure Hybrid for that also. So you will not incur any licensing cost that is required by this OS. Okay, after this, what we have to do is we in the networking tab we will check whether AT and these two particular ports are actually open for us or not. And in the monitoring, we'll disable any sort of boot diagnostic that is required. Okay, so we will not attach any disk. We can keep like the default in this case. Yeah, in networking, so you can see that we can allow the selected ports that are there. So I am selecting a HTTP 80 port also to be open. So I've opened two ports as of now. Okay, and now I will go ahead and review, just click on review and check whether the validation has passed or not. So this is important, guys. So if there will be any some errors will be there in the provisioning. So this you won't get this green tick, which is actually telling that the validation for this resource has passed. And you can see that I am actually also getting what will be the cost of this particular resource. So because I am in India currently, so it will incur me like 9 rupees for per hour. So you can accordingly calculate it for dollars or whichever geography you are there. Okay, and then all we have to do is click on create. So this will initialize the deployment, and it will take 2-3 minutes. Let us wait for this to get deployed. So you can see that the deployment is in progress. So it has created all the network requirement that is needed by a virtual machine, like NSGs, public IP address, the virtual network interface card. Now it is creating a virtual machine for me. Okay, meanwhile this is getting deployed, let us discuss the lab. So after we have provisioned this thing, we will connect to this virtual machine, and I'll show you how you can actually connect to a virtual machine through RDP. And once we connect to this machine, what we will do, we will actually, because this is a Windows server that we have provisioned, so we will install the web server roles and test this application also, that whether we are able to access this server or not. So you can see now the resource has been provisioned. So you can see it is provisioned under this resource group. You can either click on this resource group or go to the machine, or you can click on go to the resource. And in the connect, you can click on RDP, and you can click on download RDP file. It will create this RDP file for you. Just click on this. Okay, click on connect. Okay, I will use a different account, and I will use this password, and the username for this was Azure users. Let me just copy this. There will be a certificate thing. Just accept this for now, and we will log into our the Azure VM that we have provisioned. So now the machine is booting up, guys. This is booting up, guys. Okay, so yeah, so we are in the machine now. Okay. Now the next thing that we had to do is, now once we are in the machine, we have actually connected to the virtual machine also. We downloaded the RDP file for this thing. We have connected to this machine. The next task that we have to do is we have to actually install the web server. So for that, we will open PowerShell in our virtual machine as an administrator, and we'll run this command. So let me just open PowerShell. Okay, so and yeah, we have to close this thing for now. Yeah, just right click on it, run as administrator. Okay, and just copy, and I'll just run this thing. So it is installing the web server on this particular VM that we have provisioned, and then we'll access it from the public IP. So I'll show you that how you are actually accessing this web server also. It's taking some time. 90% done. Okay, now you can see that we were able to install the web server modules and all of the things that are required. Okay, the next task that we have to do is Okay, so what we can do, we can actually close the RDP connection for now. So because we have already installed the server and everything, we have to get the public IP address of the VM. So this is in your overview section. This is the public IP address. So for your the VM that you will provision might be there. It will have a different public IP. Okay, now let me just close this thing for now, and so you can see that we were successfully able to install the web server for this machine also. And this is something you guys can also test. So I'm just posting the link for this thing in the chat. Okay, Jen. So benefit of the VM will be your logic apps or your function apps. They will they obviously they will those are serverless in fashion, but sometimes you also need some command over the infrastructure. So then you would go for an IS option and you will provision a VM. Additionally, your VMs would be comparatively cheaper if you are going for PaaS solutions. So no doubt Azure functions only incur cost when you're running the code, but if you properly use your VMs and if you are really skilled enough, you can actually have you can have a cheaper VMs also which can do the same work for you. Okay. So the benefit could be of using the VM is higher flexibility over the environment, and the benefit of Azure function could be you don't need to manage the infrastructure. Okay, so I guess that answers your question. uh, you can post. Okay, yeah, so this is the URL for the web server on which we have uh, uh, like uh, created our web server. Okay, so guys, what I'll do so that we don't incur any cost, so uh, once you guys are done, so you can actually go ahead and stop this virtual machine, then it will not incur any cost. Otherwise, what will happen, this the move till the time this virtual machine is up and running, this will keep on incurring the cost also. So I'll stop it for now. So if anybody is testing, just tell me, I will just restart this machine and you can actually uh, uh, just open that web server URL also. Just click on stop. What it will do, it will not incur any additional cost while we are actually going through the session also. Okay. After walkthrough of creating a virtual machine, then we have Azure App Services. So it's a fully managed platform to build, deploy, and scale your web apps and APIs quickly. So if you are creating web apps, you want to deploy them, then you can Azure App Services is one. It's a fully managed platform where you can do it, and it works with your .NET core. So obviously .NET is Microsoft's own language, so they almost try to put it everywhere in their Azure ecosystem. But apart from that, you have Node.js, Java, Python, and PHP support also present. So you will see a lot of Python like Flask or Fast API or Django apps also being run on Azure App Services. And this gives you an enterprise grade performance, security, and all the compliance requirement that is needed. Okay, next lab is for our to create an app services, and on this app service we will actually deploy a Docker image which is stored in an Azure container registry in Docker Hub. So we will create a new web app using a Docker image. Okay, so for that in your labs, if you can actually go back and you can go to this create a web app section. So what you have to do, you have to again, we are already in the Azure portal, and from the Azure portal, all service based, you have to actually search app services. Okay, click on app services, go ahead and click on create. Sorry guys, I've a bad throat today. So, and then I've selected my subscription. This time I will not create a new resource group. I have already created one resource group, and let me show this resource group to you also. Just go click on this Microsoft Azure thing. Under this, okay, we don't. Just click on resource groups. Okay, it will auto complete. So you will see that I have these many resource group. Okay, under uh, let me just select this subscription also, because this is the subscription we are working on. So let me just select filter out this subscription. So within this subscription, I have this resource group that I created when I was creating my virtual machine. So you can see when I was creating my virtual machine, all of the supporting resources that are needed by this virtual machine also got created in this particular resource group. So now I will only use this resource group for all my labs. Okay. So I will not create a new resource for all the labs. So later on, whenever I will have to remove these services after labs, I will simply delete a single resource group and all of these services will be gone. So I'll click on app services, click on create, and I'll choose my own resource group. Okay, I'll give this web app a name. So I will give this my Docker this a name. Maybe to keep this unique, I'll use a. Okay, so you can see that this tick is telling me that this name I can actually use it. Okay, next thing that we have to do, we have to actually publish a Docker container, which is type of a Linux and in the East US region. Okay, so we are not publishing any code, we are actually publishing a Docker container. Yeah, so we are using a Linux machine only, and for the region we can use East US region. Okay, next we'll go to the we'll choose the Docker image that we need actually. So for that we'll go with the single container options. So we just need one container to run this particular web app. So we'll just go with a single container, and the image where this Docker registry is present is from Docker Hub, and this is the image and its tag, and this is a public image. So we'll choose Docker Hub. This is a published image. So yeah, so this is the image and its tag that is needed. Okay, then after that, all you have to do is you have to click on review and create, and you can also give any startup commands that you need. So you will be mostly doing using these things when you will be very advanced, like you want to run some script the moment your web app is loading. So you can have all of these things also here. So in the monitoring section, if you want to put any, let me show. So if you there is an service in Azure which is known as application insight, where you can actually collect all your logs and everything. Tags is just a way to like tag your resource. Maybe if you are linking this resource to some maybe business unit or maybe some project specific, so you can do that also. I'll click on review and create. So you can see that the web app cost is very high. So it it will almost take like 5,000 rupees per month for this premium SKU. Okay, so I'll click on create. So it is provisioning an Azure ACI instance app service for me. Okay, so now we'll go to the resource. So this resource will also be present in my resource group only. So you can see the status is running for me, and this is the URL for this particular resource. So I'll just like go through the labs also. So once your resource is up and running, so just monitor this status. Sometimes it will be in preparation status only, and this is the URL for your uh, web app that is there. And you can directly just so I've already copied this thing, so you can click over here, and so you can see that this web app that we have created is up and running, and it is showing that it's using your a Docker which is being deployed. Okay, so for you guys, I'll just post it in the chat if you guys want to open this. And you will have a different. Are you deploying the web app on the VM that you created? Okay, Jen. So I'm not deploying it on the VM that I created. I am deploying it on Azure App Services. So it's a different service. Uh, the in the previous exercise, what we did, we created we installed the web server on the VM, and this time we are creating it in the Azure App Services. Next, we will do it on the ACI instance, container instance. Okay. So this is the so you will have a different URL, guys. So whatever URL you choose, you will have a different URL compared to me, and maybe like at the end of the day today also, I will delete these resources. Okay. Okay. Next thing that we had to do is so let me meanwhile I see that I can pause it or not. Yeah. So I'll pause this also for now because it will keep on incurring that cost. You can click on stop and just click on yes, it will stop the web app for you, and then you won't incur any like cost also. Okay, after creating an app service, next task is to talking about Azure Container Services. So Azure containers are very lightweight, virtualized environments. So I guess you guys would know a bit about Docker or Kubernetes. So nowadays, what is happening that people are packaging their application under Docker images and other things, and they make sure that the main reason behind this is they want to remove the underlying dependency on the operating systems. So if you create a container image of your application, you can be 100% sure that whether it is running on a Linux host or via Windows machine, the app will run exactly the same in both of the OSs. And that Docker image is just a very stripped down version of your uh, operating systems where all only the essentials, the bare essentials that are required by your applications are present under that Azure your container. Okay, so for your container services, you have two things. First is your Azure container instance. So it is also a PaaS offering that runs a container in Azure without the need to manage any virtual machine or additional services. And then comes your Azure Kubernetes service. So your Kubernetes is an orchestration service. So whenever we say orchestration service, it's an orchestration service for containers. So there will be multiple containers which your Kubernetes will actually manage for you. Okay, so they are actually known as pods in in Kubernetes terminologies, and each of these pods will be actually running your application. So if you have more traffic on your website, a new pod will be automatically created using the container image. And if the traffic will always obviously like be less, then it will automatically scale down for you also. Okay, next task is to create like uh, like deploy an Azure container instance. So what we will do, we will maybe do it tomorrow, guys, because we are hardly left with 1 or 2 minutes. So if you have any questions, you can post it in the chat, or we can like call it off for today, because this will actually take some time.